All right, guys, today we're going to take a look at congruency. So we're going to look at congruent segments and congruent rules or theorems. So the first thing, let's talk about congruent segments. So definition of congruency just means that things are equal to each other. So when we put that word with the word segment, congruent segments, we're talking about two lines with the exact same length. Now in geometry, we often refer to it as being congruent because they are actually two separate segments, but they are the same. So they're equal in their length, but they're not equal in the fact that they're exactly the same thing. So we often say congruent in geometry to just note that they are the same length. So looking at this example, if I had two pictures, exactly the same lines here, PQ and line RS, if I got out a measuring tool, or in this case, they were just copied and pasted with some different letters, so they are exactly the same in length. So here would be how you'd write the congruency segment. Line PQ is congruent to, notice the symbol, it's an equal with a little tilde or a little squiggly above it, and it's equal to line segment RS. That statement means that those two line segments are exactly the same length. And then from that definition, we can also say that they're equal. But again, this is typically not used in geometry quite as often because they're not the exact same line, but they are the same length. All right, so let's look at some examples. So looking at this number line, let's see if we can determine whether the following statements are true and false. So we're going to find the distance of segments to see if they are equal to each other. So this first one here, if I'm looking at AC, and it actually kind of writes it out here for you, AC is congruent to EG. If I come up here, here's AC. That would be a distance of 2. You can either skip count or you can also do your subtraction. Remember, distance is always positive. So that would be a distance of 2. And I'm just going to come down here and write it. EG, if I looked at that one, okay, here's EG. And again, looking at that distance measurement, 0 minus 2, or again, you can kind of hop and say, oh, that is also a distance of 2. So looking at that, 2 is congruent to 2. It is. So that answer would be true. So come over here and highlight it yellow. There we go. It's true. All right, let's take a look at number 2. I'm going to clear my board. We can move on to the second one. So the second one here says ED is congruent to FH. So let's look at ED on our line. Here's ED. It is a distance of 1. And FH, oh, you should notice even by the colored lines up there, it is different. It is actually longer in length. It's got a distance of 1, 2. So when it's asking you, is that true? Is ED congruent or equal to FH? Your answer should be false. Okay, let's take a look at the third example here. So EF equal to HG. So EF, oh, let me come up here and erase. EF, distance of 1. HG, also distance of 1. So this last one, you should see that they are exactly the same in length, so this last one here is true. Now sometimes it might ask you to list congruent segments, and you're free to list them however you want, as long as you have 2 letters to describe a segment. We need a starting and a stopping point. So just to give you some examples, we could say AB is 1. Now there are so many options. We could choose DE. I could choose GF. You can go left to right. You can go right to left. I'm going to come here and I'm going to choose this one. And if I'm going to label it, again, I'm starting and stopping. You can go left to right. That's the most natural. Or you could go F to E. Either way, the distance would be 1. So you could write EF. You could go for measurements that are more than 1. I could say 1, 2, 3. Now I'm starting at A and I'm ending at D. That is a distance of 3. So again, I can pick any other distance I want as long as it's 3. 1, 2, 3. And I could say I to F. Okay, let's try one more together. Actually going to go ahead and clear out my number line there so it's a little easier. So F, I could say BD, that's a distance of 2. And I could choose any other distance of 2. I can even overlap. I could say A to C. So if I was going to write that down, A to C has a distance of 2, and B to D also has a distance of 2. So again, a little more free range, but you're just showing me that you understand that congruent line segments have equal distances. All right, so let's take a look at some congruence theorems. Now the word theorem, it's fancy, right? It's just referring to rules of congruency. And some of these we sort of talked about in kind of a discrete way when we were labeling congruent segments, but the reflexive congruence, this very first theorem or rule, just says, hey, you can switch the order of letter and it is still the same. So again, AB is congruent to AB, or you could write it AB is congruent to BA. So again, just saying that AB, this segment here, can be written as AB, or it can be written as BA. Reflexive just means you're switching the order of the letters. Okay, the second rule or theorem, it says symmetric congruence, which just switches the orders of the segments. So let's take a look. This first example here is AB is congruent to CD. So here's AB, it's a distance of 1, and they're saying that it's equal to CD, distance of 1. You could also write your congruency statement the other way around. So AB we talked about first, making it congruent to CD, or you could write the exact same congruency statement, just switching the order of how you say it. CD is congruent to AB. It's kind of like saying first name, last name, first name. It's the same person. Heather McElhone, McElhone, Heather. Same person. So again, symmetric congruence does the same, sorry about that, does the same thing in geometry, just switches the order of the segments in your listing. And the last one down here, transitive. Transitive congruency makes connections between congruency statements. So this is kind of like saying Mrs. McElhone is the same height as Mrs. Mertz. Mrs. Mertz is the same height as Mrs. Keurig. So Mrs. McElhone and Mrs. Keurig must be the same height. You're making connections along 3 different segments. So sort of, if we take a look at the example, AB is congruent to CD. Okay, AB is the same length as CD. And CD is the same distance or the same length as EF. They're all distance of 1, right? So the very last part makes connections, again, between the very first line segment. Hey, AB also must be the same distance or length as EF because they're all a distance of 1. So again, you're making connections between 2 congruency statements. AB is congruent to CD. Let's take a look at how it's written out. And CD is the same as EF. So AB is the same as CD. CD is the same as EF. So then in the end, we say that AB is congruent to EF. You're making connections between those. All right, let's put them into practice. So again, reflexive switches the order of your letters. Symmetric switches the whole statement, first name, last name, first name. Transitive makes that connection between the one line segment to another segment to another segment. All right, so let's take a look. RS is congruent to CD, so we know CD is congruent to RS. So if I take a look at it, I am flipping my entire segment. I'm kind of saying RS is equal or congruent to CD. And then if I look at it here, CD is listed first, then goes over to RS. So this, I'm switching my whole statement, which would be symmetric. Look at number 2. So it's congruency statement MN, NM. So I am switching the order of my letters. the order of my letters. So that would be reflexive. And again, when you're doing this for practice, you're going to have those rules to look at. So this is kind of a little bit more off your memory while we're talking through it, but you're going to have an opportunity to look back at those examples when you complete the practice activity. AB is congruent to EF. EF is congruent to HG. So AB is congruent to EF, and EF is congruent to HG. So therefore, AB must be the same length as HG. Do you see the connections there? Orange is the same as green. Green is the same as purple. So that means orange is the same as purple. That's that transitive one. That is where you're making connections between multiple line segments. Okay, and last but not least, RT is congruent to RT. This is the exact same segment, and the order should be switched. Actually, that's a typo. It should say TR. Sorry about that. So again, this is where I would take the letters and just switch them. So that would be an example of reflexive. All right, so again, you're going to have a practice activity that's going to ask you kind of to do both. Tell me if, by looking at a number line, if things are congruent or equal to each other in length, and then looking at these congruent theorems, going through just like we did 1 through 4, and picking out what property relates to each situation. All right, good luck. Reach out if you need help.